Hi, so welcome to today's video lesson, and in today's video lesson we're going to be talking about the nth term of a geometric progression. So if you have not subscribed to this YouTube channel, kindly do so now, and let's dive into the lesson. All right, so we're looking at the nth term of a GP. So the nth term of a GP is actually given as Tn equals to a, then the r raised to the power of n minus 1. So this is the formula for the nth term of a geometric progression. That means if you are looking for any term in the geometric progression, this is the formula to use. So where your a is equals to your first term, and then your r is equals to your common ratio. So your n is your nth term. All right, simple as that. So let's take an example. So let's say that the first term of a GP is actually 7. So while the common ratio is 3. So you have to find the 11th term. So this is actually a GP question. So how do you know it's a GP question? Because of the common ratio. That's how you know that it's a GP question. If it's an AP question, it's going to have a common difference D. Alright, good. So we have to find the T11, and remember that Tn is actually equals to A r raised to the power n minus 1. So that means T11 has to be A is 7. That's 7 into what are r? R is 3 raised to the power of 11 minus 1, and so that gives us T11 equals to 7 raised to the power of that's 3 raised to the power of 10, and 3 raised to the power of 10, that's 7 multiplied by 3 raised to the power of 10 is 59,049. Let me write that again. 59,049. So multiplied by 7, what do you get? So T11, that's 413,343. So this is the 11th term. Alright, so let's take another example to explain this further. Alright, so let's say that the 8th term of a GP, T8, is equals to 640, and then the first term is actually 5. So you find the common ratio as well as find the 10th term. So how do you solve for this? Now remember that for geometric progression, how do you know it's a geometric progression? Because of this r. That's how you know. It's equals to a r n minus 1. Okay, so T8 is equals to a. A is 5. 5 multiplied by what are r? We don't specifically know. R, what are n? N is 8. 8 minus 1, and T8, all of T8 is equals to what? Is equals to 640. So therefore, I'm saying 5 multiplied by r, 8 minus 1 is 7, equals to 640. So I can divide both sides by 5. So then r raised to the power 7 can give us 640 divided by 5. That's 128. So I can take the 7th root of both sides, the 7th root of both sides, just to eliminate that 7. So 7 can cancel that 7. And so r becomes 7th root of 128 is 2. So that means that our r equals to 2. So we are also to find the T10. So therefore T10 has to be A. What are A? A is let me check. A is 5. 5. Then what's R? R is 2. Then raised to the power 10 minus 1. And so T10 becomes 5 multiplied by 2 raised to the power of 9. And what's 2 raised to the power of 9? 2 raised to the power of 9 is 512. And so that's 5 multiplied by 250. 200 and, sorry, what am I writing? That's 5 times 512 is 2560. So this is the answer to that question. So I could continue to take different kinds of example, but basically let me just take one more example and we'll call it a day. Now, let me clear off my screen. All right, so let's say that the following gives a geometric progression. So let's say that this is a geometric progression 2, then P, then Q, then 250, so and so on. So now let's find P and Q. So how do you find P and Q? Now, to solve this question, first know that A is equal to 2, right? That's the first term. And that this is your first term, second term, third term, and fourth term, okay? And your T4 is equal to 250. Now, how do you know this is even a geometric progression or arithmetic progression? Now, this is just two terms between 2 and 250. That's a large difference. So that should be a common ratio. That means they are multiplying. It's a multiple. The difference is a multiple. Okay, so now remember that Tn is actually equals to AR raised to power n minus 1. And if that's the case, therefore T4 has to be what's A, and A is 2. That's 2 into what's our R? We don't even know. Okay, but we know that n is what? 4, as we're solving for. 4 minus 1, and all of that T4 is actually equals to 250. Okay, so that tells us that 2R raised to the power of 4 minus 1 is actually 3 raised to the power of 3 is equals to 250. So I could divide both sides by 2. So that means my R raised to the power of 3 is actually 125. So I can take the third root of both sides. So 3 cancels out the root. And so R becomes third root of 125. I think that's 5. 5 is matrix 125. So R is equals to 5. So we are asked to find what exactly? Second term and the third term. So can we, since we have our A is also equals to what? A equals to 2. So we can find our second term, which is our P, and that equals to A. Remember that Tn equals to what? ARn minus 1, right? So what's our A? Our A is 2. What's our R? Our R is 5. What's our N? Our N is 2. That's what we're solving for. And so that gives us 2 into multiplied by 5 raised to the power of what? 1. That's 2 minus 1 is 1. 2 times 5 raised to the power of 1 is 5. 2 times 5 is actually 10. So P equals to 10. Okay. So Q is going to be what? The third term. First, second, third term. So third term, that's Q. And that equals to 2 into 5, then 3 minus 1, because this is the end. And so that gives us 2 multiplied by 5 to the power of 2. And that gives us 2 multiplied by 25, and that gives us 50. So therefore, Q equals to 50. So we have gotten our value for P and Q. So this is how to solve questions as touching geometric progression. How to find the terms of geometric progression. Just use the formula and you're going to get your answer. So if you find this video very helpful, kindly click on the like button and comment on this comment section. Just say thank you, and you can share this video to those that you think might need them. And if you have not subscribed to the YouTube channel, kindly do so. All right, bye.